Hi, in this video we're going to look at how to make a player move in a 2D game in Unity. I have a 2D platformer game here that I've been working on, and as you can see I've got a player object here, and I want the player to be able to walk or run along platforms and ground and to be able to jump and land and do things like that. So to do this we're going to need to write some code in C#, but before we can write that code to get the player to move, what we need to check is that this player object has two things attached to it, two components. So firstly, it needs to have a rigid body 2D component. So if you haven't added a rigid body 2D component to your player object yet, then what you'll need to do is go down and click on add component and then just search for rigid body 2D and click on that to add that component. Okay, so I've already got a rigid body 2D component there, and I could adjust things like mass and drag and gravity scale and things like that, but at the moment I'm going to leave those values as they are. Also, what you can do is freeze rotation on the Z-axis to make sure that your player doesn't tip over when they're moving. So I've got a rigid body 2D component, and the other component that the player object will need before we add movement is a polygon collider 2D or another type of collider, depending on the shape of your player object. So it's going to need some type of collider 2D. I'm using a polygon collider 2D, but if you haven't added a collider to your player object yet, you just go to add component, and you can either search or you can go into physics 2D and choose an appropriate collider. So you've got circle collider 2D, you've got edge collider 2D, polygon collider 2D, there should be a box collider 2D. So pick the one that's best for the shape and type of player object that you have in your scene. Okay, so that's basically what we need to get started. We need a rigid body 2D and a collider 2D. Okay, the next thing that we're going to need to do is to write some code. And so we'll need to create a C# script. I've already got a folder here called scripts that I'm going to use to organize my code. So in there, I'm going to right click and create a new C# script. And if you haven't written any code before in C#, you haven't coded in Unity before, then you might want to go back to the previous video where I did a bit of an overview of scripts. But basically what we need to do is make sure that the script name starts with a capital or uppercase letter and doesn't contain any spaces. So I'm going to call it player controller. All right, and I'll double click on that script to open it up in my code editor to write my code. And I haven't attached this script to the player object yet, but we'll do that shortly. All right, firstly in this script, we're going to need some variables to store some information. Information like the speed of the player, so how fast the player is going to be moving, as well as information about which direction the player is moving in based on the directional keys that are being pressed on the keyboard. And also we're going to need access to the actual rigid body 2D component attached to the player object in Unity. So you can add your variables in the class of your scripts. So just below where it says public class player controller and the curly brace there, I'm going to make some new space and create some variables. So the first variable I'm going to create is for speed. And so it's going to be a decimal number or a float. All right, so public float speed, and I'm going to give it an initial value of 5, but you can adjust the speed value here either in the code, or because I've made this a public variable, I can actually edit this value in Unity without having to go back and forth between Unity and the code editor. So basically when you create a public variable instead of a private variable, what that means is that not only can you access and change the value that variable, the information that variable is storing here in your code, but you can actually go into the Unity editor, and even while the game is actually running, you can change values to test those changes and see what happens. We'll look at that in a little bit. So this is a public variable. It's of type float, so it's a decimal number. We can have decimal points. Its name is speed, and I've said to give it an initial value of 5, and the F there just stands for float. So you need to put an F at the end of a number if it's a float and not an int or integer. And we'll just end that line with a semicolon to say that's the end of that statement. So the speed is 5, and I'm going to make another variable. This time, I'm not going to make it public because I don't want to be able to edit this value in the Unity editor. I only want to be able to change it in the code. So it's a private variable. It's going to be a float as well. And this one is called direction, which is going to be set to 0 to begin with. Now, the way that this works is, and I'll just go back to Unity so we can see this. If you go into Edit and then down to Project Settings and the Input Manager, if you click on that, this is where you can actually edit which keys are assigned to different actions in the game. So for movement, like moving horizontally or vertically, for jumping, for firing weapons, all the different types of actions, you can actually map keys to those actions in Unity rather than having to specify which keys are being pressed in your code to do different things. So for example here, if you click on axes, you just click on the little arrow there to reveal that, and then you reveal horizontal. For horizontal movement, we can see that the negative button, so that means movement to the left, is the left arrow key. If the positive button, so movement to the right on the x-axis, is the right arrow key. But we also have alternative buttons here for left and right, which are A and D. So this means that at the moment, the Input Manager is programmed so that either the A and D keys or the left and right arrow keys on the keyboard can be used for horizontal movement. Okay, so I'm not going to change that. We can also see which keys are mapped to vertical movement, and things like firing and jumping as well. The space bar is mapped to jump. So we can edit those in here if we want, rather than having to change them in the code. And what that also means is that when the player is playing the game, we can give them the option to choose which keys they want to use for different actions. So that's the Input Manager. I'm going to go back to the code. And the way that this works is with the Input Manager, if you press the A key or the left arrow key, so that's for left movement, then this number here is going to become a negative number. All right, so it might become -1. If you press the D key or the right arrow key for right movement on the horizontal axis, then this number will become a positive number, like 1. And if you're not pressing any directional movement keys on the keyboard, then this value is just going to stay at 0. All right, so it's a negative number for moving left and a positive number for moving right. Okay, so just remember that. So we'll need one more variable. This one is private as well, and it's going to be a rigid body 2D. All right, so double click on that, or you can just type in the whole word, but it's private rigid body 2D, and I'm going to call this player. All right, now I'm not going to give it a value at the moment, because what I'm going to do is in the start method down here, I'm going to grab that component because it already exists. We've added in the game a rigid body 2D component to the player. So what we want now is access to that component so that we can change things like its movement or velocity, and we can work with the player object to make it move around the scene. So we're going to get access to the rigid body 2D component and refer to it as player in this script. And to do that, we're going to say player equals get component rigid body 2D. It's really important to spell it just like that, with an uppercase R, lowercase b, and uppercase D at the end there. And then just open, close parentheses at the end there. So we're getting the rigid body 2D component, and it's going to be in this variable player. We're going to refer to it as player from now on. All right, and that's in the start method. So that means that that's just initialized at the beginning of the game as soon as this script starts to run. Next thing is in the update method, which, remember, this method is, this block of code here is repeating constantly as the game is running. Every single frame this code is running. So what we're going to be doing is every single frame finding out which direction the player is moving in based on which keys the user is pressing on the keyboard. And then we're going to use that to that value, the direction value, to say how fast the player should be moving in that given direction. So in here, we'll say direction equals input dot get axis, and then in parentheses and quotation marks between those, we'll set horizontal. All right. So direction equals input dot get axis horizontal. What this means is now we're referring to that input manager, which I mentioned before. If we go back to the project settings and input manager, now what we have is access to this information here, the horizontal axis. All right, so we know which keys are mapped for left and right movement, both left and right arrow keys and the A and D keys on the keyboard. So we're going to get that information here to find out which direction the player should be moving in. So as soon as the user presses either the A or the D key or the left or the right key on the keyboard, we're going to get a number back, which is either going to be a negative number if they're pressing one of the left direction movement keys, or a positive number if they're pressing one of the right direction movement keys in that's specified in the input manager. Otherwise, this number is just going to be 0 if the user's not pressing any key at all. So we'll find out what the direction is, and then we're going to check, is the direction a positive number or is it a negative number? And we'll do that by writing an if statement. So you can say if, and then specify a condition. Firstly, what I'm going to do is just check if the direction is greater than 0. And because this variable is a float, we need to put an F at the end of that number there. And then between curly braces, I'm going to specify what will happen if the direction value is greater than 0. So in other words, if the user, the player, is pressing either the D key or the right arrow key on the keyboard. What we're going to do is modify the player's velocity. All right, now that we have access to the rigid body 2D component, we can change the velocity, and we're going to say player.velocity equals new vector2. Now vector2 is something that can contain two values or two pieces of information about the x-axis and the y-axis. So in this case, we're going to be specifying the velocity for the x-axis, or changing the velocity for the x-axis and the y-axis. And those two values are going to go between these parentheses here and separated by a comma. So for the first value is going to be for the x-axis, and the second value after the comma is going to be for the y-axis. So on the x-axis, what we're going to do to specify the velocity is we're going to take the direction value, which is either going to be a negative or a positive number, depending on whether the player has pressed the left or right direction movement keys. And we're going to multiply that value by speed. So direction multiplied by speed. Okay, so that's for the x-axis or horizontal movement. Then a comma. For the y-axis, what we're going to do is just maintain the current velocity on the y-axis. We're not going to change the velocity for the y-axis. We're just going to find out what the current velocity is for the y-axis and then just keep it as that. Okay. The reason why is because later on what we're going to do is add some other code for jumping, and if the player's jumping or falling, then we want to still be able to make them jump while going left or right, or fall while going left or right. And so here we won't want to change their y velocity. We can change that elsewhere in the code for jumping. Okay, so this block of code here will only run if the direction is greater than 0. So if the player is pressing either the right arrow key or the D key, that direction variable becomes a positive number, and that means that this line of code here will run. And the direction variable, if it's a positive number, let's say it's 1, all right, then that's going to be multiplied by the speed, and that's going to be the velocity for the x-axis. It's going to be moving right at that certain velocity. And then on the y-axis, it's just going to keep whatever velocity it currently has. It's going to stick with that value. Now what we can do is specify what will happen if the direction is in a negative direction. So if direction is a negative value, in other words, left. So else if direction is less than 0, what we're going to do is actually just copy and paste the code for right movement. So copy the code for right movement, paste it in for the block of code for left movement, because it's actually going to be the same. Now, the reason why I've separated these into two separate blocks, one for right movement or right direction and one for left direction, is because later on, and we'll go through this in another video, but later on we're going to change things like animation and the sprite for the player, whether they're facing left or right. So if they're moving right, we'll make the player face in the right direction, and if the player's moving left, then we'll make them face or look in the left direction. So that's the reason why I've separated this into two different blocks here. Otherwise, what we could really do is just check if direction is not equal to 0, and then just use this line of code to make the player move either left or right. Okay, these two lines of code here can be exactly the same because they're both, what's going to happen, the direction that the player moves in is going to be based off what the direction variable is, so whether it's a negative or a positive number. Okay, lastly, I'm going to add an else, which just means this line of code, this block of code here is going to run if neither of these conditions have been met. So if the player is not moving right, and if they're not moving left, then it must mean that the player's still. So none of the direction keys have been pressed on the keyboard. And so what we'll do is we can again just copy and paste that line of code, but we'll just change velocity for the x-axis to 0. Okay, and so what this is going to do is basically if the player's not pressing any of the keys on the keyboard to move left or right, then we're just going to say that velocity for the x-axis is 0. And the reason for that, the reason why I'm going to do that is because sometimes if your player is on a platform that's maybe tilted or on a bit of an angle, and you're not actually pressing any keys for movement, the player might still be moving just a little bit. They might kind of be sliding a little bit because of gravity. So just to prevent that, if we don't want the player to be sliding when none of the movement keys are being pressed on the keyboard, then what we can do is just say 0 for x-axis there, and that will just keep the player still when we're not pressing any keys. That's basically it. So what we'll need to do now is just save that code, and we can go back into Unity. All right, and Unity has just recognized that the code's been changed, so it's just reloading that. But we still haven't actually attached this script to the player yet. So I'm going to click on that script and drag that script onto my player object. All right, if I click on the player now, we should be able to see that that script is there. And because that speed variable is public, all right, the other two variables are private, but because the speed variable is a public variable, what that means is we can now actually see that variable in here, and we can change that if we wanted to. So I could increase or decrease the speed and test it out in the game. All right, I'm going to run this game now. And now that I've landed on the ground, I'm going to press the left arrow key and the right arrow key and the left arrow key, and we can see I can move the player around. And the same for the A key and the D key. So I can press either A or D, or left or right, and move around. All right. Now, one thing I did forget to mention before was that I did mention that for the player, we need a rigid body 2D and a collider component. But for the ground, whatever we want to be able to walk or move along, that's going to need just a collider. Okay, it doesn't need a rigid body. We don't want the platform to be able to fall down. It's just staying still in space, but we do want it to have a collider or a hitbox around it so that we can hit the ground and then move across it. So make sure if you're falling through the ground, make sure that it's got a collider attached to it. All right, so that's working. One last thing that I'll just show is if we go back to that script, in the update method here, just after we get the direction and store that in the direction variable, what I'm going to do here is say debug.log direction just so that we can actually see in the console what value is being stored in the direction variable when we're pressing the different keys on the keyboard. All right, so if we go back and just let that script reload and play the game and just go to the console, we'll see that when none of the keys are being pressed on the keyboard, we're getting 0. So we see 0 being displayed in the console. Now when I press one of the keys for right movement, we can see that the number becomes positive, and when I press for left, it becomes negative. So left is negative, when I stop it becomes 0, when I press right, it becomes a positive value, and when I stop again, it becomes 0. Okay? Okay, so lastly, the very last thing is if we go to the player object and we scroll down to where that script is showing up as a component that it's attached to the player. If we change the speed variable here, increase that to 10 maybe, and play the game again, we should see that the player now moves faster in each direction. Okay, so player's moving much faster because the value is set to 10. But if we go back to the script there, it still says 5. So we haven't actually changed the value in the script. All that we're doing is overriding the value that's set in the script. So by default, the speed is 5. But if we change the speed in the script, it's going to override that value. All right. One last thing to remember is we can change the value while the game is running. All right. So if I just wanted to test out what's it look like when the speed is 5, or what does it look like when the speed is 2, for example. All right, much slower. We can change those values there just to test things out while the game is running. But really important to remember is that if we change those values while the game is running, it's not actually going to save those changes. As soon as I stop the game, you'll see that the speed goes back to what it was set to before I ran the game. Okay, so just keep that in mind. Always check that the game is not running if you're wanting to make permanent changes to those values. Anything that you change while the game is running is going to revert back to what it was before the game was running. Anyway, that's it for this video. In the next video, we're going to look at how to make the player jump. All right, so thanks for watching.